My name's Joe Young. I'm a program manager in the SQL Server product group. With me, I have my colleagues, Joachim Hammer, also a program manager, and Borko Novakovic. Excellent. Say hi. And so we own various, or I used to own some of this, but we own various features in SQL Server. And one of the things that we've worked very hard in the 2016 release is to make sure these features play nice together. So we just decided to pick a few of these. These are by no means the only ones that were designed to work together. It's not one of those situations where we build some cool stuff and toss it over the wall and, hey, you guys go figure out how to make it work. And then you come back and tell us, hey, I can't make this work with the other feature. I can't make always on availability groups work with something else. We avoid that. I know we've done a few missteps in the past, but we work very hard to avoid that in newer releases. So goals for our session before we get started. We're going to walk you through how to employ always encrypted stretched database and temporal tables. We're going to show you very briefly what these things are, what problems they solve, and why they might be good options for your environment if you face some of these issues. We're not going to go into a huge amount of depth or breadth in either of these. We do expect you to know what some of these core usage scenarios are. If you haven't seen any of these things, that's okay. We'll walk you through the basics, but the slides will not go into gory detail on every aspect possible in either of these features. The goal is really to show you how to put these things together and what problems you can solve with them. We'll also call out some of the issues and limitations. Clearly, these things will not solve every single thing under the sky, so we'll let you know when it's a good time and when it's not a good time to use these capabilities, either together or by themselves. We will be happy to answer any questions, whether it's related to these features working together or by themselves. So there will be additional content in the slides which we will not go through in detail. We're not going to stand here and read the slides to you. They are available for download, so go ahead and pull them down and go review them. But if you have questions in any of these areas, between the three of us, we can probably go about as deep as you want to, or if you want to go a little broader and discuss what types of scenarios or industries these will address, we can probably answer them for you. If not, we'll take them down and we'll send you an email. So let's get started. Actually, before we do that, just so I know who's in the room, you know who we are. How many of you either have a specific DBA or admin type role, or you play one at work? Wow, OK, 80, 90% of you. How many of you also play a developer, or you are a developer role exclusively? It's about 10%. Wow, DBAs outnumber everybody else. OK. Any, yeah, go. Getting excited there. OK, any network admins? I'm holding this up because the lights are in my face. I can hardly see anything. Storage admins? OK, a couple of them. Security people? Well, hang on. I had 80% of the room raise their hands when I said DBA, and nobody raised their hands when I said security? You're the guardians of the data. You are security people by definition. All of us are. OK. All right. Any business-only folks, folks who are wondering about how they're going to pay the next quarter's budget for IT? Just one person? OK. We might be able to help you, too. All right. So let's get into overview. We're going to start with stretched database. So why did we come up with this feature? It's in response to a lot of issues that we've been seeing over the years. And a lot of this is actually with a lot of customers, both very large enterprises and also small and medium-sized businesses prodding us and telling us that they have SQL Server databases that are growing to sizes that are completely unmanageable. We're talking about millions to billions of rows. So how big is big? How many of you have tables that exceed 1 billion row in size? Wow, more than a dozen of you. How many with more than 10 billion rows? And of these, are these relational data warehouses, or are these OLTP? We're looking for OLTP tables, 10 billion rows. Excellent. We'd love to talk to you after this. So I worked with a customer with 45 billion rows in a single table, OLTP. Anybody beat 45 billion rows? What about size? The largest single table I've worked with was 8 terabytes, one table, OLTP. Anybody have some bigger than that? So the DBA with the 45 billion rows, as you might imagine, he wasn't too happy when we asked him what was his reindex experience. So the challenge is these poor DBAs would go ask the end users, hey, you've got all this data, which ones of these don't you really need anymore? Because some of these are 5, 8, 20 years old. And the user's like, well, I don't know. I think I need to keep some of this stuff online. Do you know what kind of periods you need them? Don't know, but when I need it, I need it. When the auditors come in and they ask me all these questions about this account that I've had for 20 years, I better be able to answer questions quickly because I want to get the auditors out of my office quickly. And the poor DBA then has to figure out, well, oh yeah, there's the main reindex problem. Another problem is when you have these tables that are really large, but they're 80, 90, some of these 99% cold, what happens to your backup and restore story? We've got users with databases close to 20 terabytes, 80 plus 90% is cold. Guess what? When you restore, it takes you offline for almost a day, waiting for cold data to get back online. So those are some of the problems we're trying to solve and make life easier for our customers, not just the DBAs, because if the DBAs can't meet the SLAs, the business will suffer. So you could keep adding storage to your data center, keep buying more storage, buy more frames, but it doesn't really solve your reindex problem unless you decide to put terabytes of cold data in your SSDs. Those of you who have a lot of money in your next year's budget, good for you. But for the rest of us, that's probably not feasible. You can move it to another location. Pretty much every third-party solution that exists today will take your data, truncate your original tables, put it in either a flat file or back it up and remove the originals, and then take that into a different system. In some cases, they put them on a truck and cart them off to places like Iron Mountain and whatnot for really, really cheap. The challenge is the data is either nearline or offline. You cannot access the data from your existing application. That presents a problem. Remember the auditors we talked about earlier. I've gone through a few of those things. Not very pleasant when they ask you for the data and you say, it'll take me about 2 weeks to bring it back. And that's assuming I have enough space locally to restore that giant 20 terabyte database so you can pull the 200 rows for this one account that you're looking for. So that makes life a little difficult. Delete older data. We've met up with customers who do that also. The most common response is, we don't really know if we need it or if it's valuable. We are simply out of space. If we do not delete regularly, we just cannot take in new transactions. In some cases, these customers are thinking, you know what? I think we're violating some law somewhere. We're not really allowed to delete this data, but we can't help it. So if these are not options for you, welcome to Stretch Database. At a very, very high level, Stretch Database allows you to tell SQL Server what data is cold. So you tell SQL Server, this is cold, either the entire table or specific rows within the table. These things are cold. And from there on, SQL Server will then decide, OK, where in Azure do you want to put it? Give me a credential, give me a target, a region or a data center or a specific server. You tell me that. Once you've given us that, SQL Server will then figure out, you've got cold data here. I will gradually pick up this data that you define as cold and move it into Azure transparently. You don't have to worry about what happens. You don't have to go out there and figure out which one of these got to go. You just define what is cold. SQL Server takes care of the movement for you. It's done in a trickle manner, so it will not affect your production systems. You will not see the production workloads get impacted. So that's one of the things we work really hard on. The other thing, none of your queries change. Your existing queries still continue to talk to the local SQL Server, but the cold data could reside either locally, because it's still waiting to be moved, or the cold data could already be sitting in Azure somewhere. You don't care. SQL Server figures this out. Looking at metadata, it knows that, hey, this table is stretched. I've got some of this stuff local, and I've got some data in remote. The query that you just sent to me locally, I will break that into 2 parts, push part of that into Azure, let that execute remotely, bring only the result sets that you need back, and then union all with the local result sets that you run on the local data set. You don't have to worry about how that happens. And all of this is always via secure channels. If we cannot get a secure channel with a verified certificate, we will not talk to the remote source. So we make sure that there's no chance you can misconfigure your environment and end up getting attacked by some man-in-the-middle setup or somebody sniffing your wires. If we cannot get a secure channel, we will not talk to the remote endpoint. So that's Stretch Database in a nutshell. We'll go into a little more as we walk through the implementation and demos. Everybody with me so far on what Stretch Database is? Excellent. Anybody tried Stretch Database so far? Used it? 1 or 2? OK, great. So keep Stretch Database in mind. Now we're going to walk through what Always Encrypted is, and then we're going to walk through temporal tables, and we'll show you how to cobble them all together. So for Always Encrypted, welcome.
There you go. So quick context switch. Security is everywhere, and let me tell you a little bit about the encryption technology that's at your disposal to help secure some of the stuff that's moving into the cloud. Now, before 2016, if you had sensitive data and you wanted to encrypt your data, protect the data, your choices were somewhat limited. Sure, you could use encryption at rest, or TDE as we call it, and that would give you protection of the database files and the backups and so forth in case they somehow got away from you. And then, of course, you could also use what we call encrypt by key or decrypt, these crypto libraries that we're offering. But that required you to encode the logic, the encryption logic in the application, so the application was aware of the columns or the fields that you were encrypting and had to encrypt and decrypt. So that put an extra burden on the developer. Now, fast forward with SQL Server 2016 and now also in the cloud with Azure SQL DB, you have another choice. It's called Always Encrypted, and this is our latest column-side encryption technology that allows you to, if you have sensitive data, so you identify columns with information that needs to be kept secure, you can identify those columns and then you can choose to encrypt these columns with either a randomized encryption algorithm or what we call deterministic encryption, and keep those columns encrypted while they're out of your control, while they're out of the trusted zone. And furthermore, you keep the keys, so you're in control of the certificate that protects these columns. And then, in addition to that, SQL Server can actually operate, if you choose deterministic encryption, SQL Server can actually operate to some extent on these columns. So right now, as you can see, we're supporting equality and a few other operations on that encrypted data. So with this new technology, not only are you in control, we actually guarantee that SQL Server or the database server, will not have access to the unencrypted data or to any key material in unencrypted format. So you're in control of the data, and essentially you take SQL Server out of the equation. So on the off chance that SQL gets compromised, that there is some breach happening, you can rest assured that the data that you protect with Always Encrypted remains protected. And then above everything else, on top of that, I should say, there's the transparency angle, which is not to be sort of underestimated. So rather than these crypto libraries that I talked about earlier, this one is to a large extent completely transparent to the application. So it's a great solution. We've got a lot of feedback from you, from customers. And here we go. Let me just walk you through a very high-level sort of conceptual schematic that illustrates some more of these points that I just made. And again, as Joe said, it was a very informal session here, so feel free to interrupt or ask questions as we go along. So here's the setup. We've got SQL Server at the back end that has some information about customers. It could be healthcare or patients here, and there's some sensitive information, social security number and name. And we've chosen to encrypt the name with randomized encryption, AES-256 randomized encryption algorithm, and social security numbers protected with deterministic encryption. And we made that choice because we knew ahead of time that, yes, we do need to do lookups on social security number, while the name field really at this point, we're not doing anything with names. We just want to make sure it's protected. And then on the other side, we have our trust boundary that encapsulates the application and in this case, the ADO.NET driver. And most of the secret sauce is in that driver. This is where all the transparency happens. This is where encryption and decryption happens, because remember, this is a client-side encryption scheme here. So we've got the setup here, and so the transparency comes in where, let's say, the application. Where is it? Oops. There. Sorry. Oops, too much. So the application fires off a query. It's a lookup on our customers or patients on social security number. And so when that query arrives at the client driver will do a bunch of things. It'll first inquire against the SQL server, the server in the background, as to what the schema looks like and whether or not any fields are encrypted and what encryption technique has been used there. to make sure that, as I said earlier, no sensitive information ever flows in unencrypted form onto SQL Server. So as part of that inquiry, the client driver also gets the encryption key from the server. And just like with TDE, we're dealing with an encryption with a key hierarchy where we have the actual, we call it a column level encryption key, which is protected by a master key. We call it a column master key. The master key is something that remains in your control, and you can decide to store this either in a Windows secret store. You can put it in an HSM. You can also, if you're in the cloud, you can store that in Azure Key Vault. So you have control of that. And then there's the encryption key, which, as you can see in this picture here, is stored on the server, but it's stored protected with the certificate, with this master key, so that it's never actually useful on the server. So all of this comes together in the client driver as the query arrives. And then the client will then, the client will do the necessary work. In this case, it'll encrypt social security number with our deterministic encryption algorithm and then submit this query that you can see on the screen to SQL. SQL will just take this query and will just execute it blindly against the schema underneath. And here's where this deterministic encryption comes into play. It'll do a lookup against social security number, and then, as you can see here, there it is, it'll find the result set. That is returned to the client driver, again, still in encrypted format. And then the client driver will then, in return, do the decryption. And to the application, this looks like just a regular interaction with the back end. There was no extra work necessary as part of the application in this case to make this work. One last word before I hand it back over to Borko. We get a lot of feedback on, gee, this is all you can do is sort of equality. It doesn't actually, it may sound bad, but it's actually not as bad as you think it is. Because if you think about this, could be a healthcare, some sort of a clinic, for example, and to them, social security number is really a burden. So the only time you would actually need social security in the clear is when you check in at the counter, you talk to the nurse, you say, here, this is I am, and here's my social security number. He or she needs to do a lookup on it, and then for the rest of the lifetime of your record there, that social security number just needs to be protected. And HIPAA laws are pretty strict, and so you better do a good job with that. And so in this case, Always Encrypted is perfect technology for this. You encrypt it, you store it away. If you do need to do the occasional lookup, we support that. So there isn't really a whole bunch of fancy arithmetic or other things you need to do. Now, granted, we understand we need to do, there's additional operations that need to sort of be supported, and when we're working on this, but for a first version, I think this is a very useful technique. So I'll hand it over to Borko, and let me advance it here.
Thank you.
There you go.
So this is the third feature, very specific feature and specific scenario. And before I explain the motivation behind introducing this new feature, I'd like to check how many of you actually tried temporal tables in SQL Server 2016. How many of you heard of this feature? Okay, looks like we are popular in the social networks, yeah. So basically, you know that the data sources today are very dynamic, and actually some companies really rely on insight they get from the data evolution, from the changing data. In addition to that, regulatory rules and compliance rules are pressing companies more and more to store historical data for future forensic analysis and auditing, right? So it really tracking how data change over time and being able to analyze those changing becomes very important to many businesses. And typical data consumers in companies like healthcare, financial services, pharma, manufacturing, they are asking themselves very fundamental questions every day. How my critical information looked like a month ago? Or when data exactly changed and how it changed? And what are the dominant trends in my data, if you wish? And answering those questions without proper support in the database wasn't an easy task, right? So people had to build different a custom solution, different workarounds in order to achieve that goal. But there was a feeling among our customers and users that this is something that needs to be part of the database offering, built as a database feature, right? And mostly because all of these workarounds that I mentioned, like incorporating data tracking logic inside triggers or inside the application logic or inside the store procedures, it was always expensive to first develop and then maintain and manage, and also error-prone. And at the end of the day, it was also inflexible and inefficient, right? So therefore, SQL Server 2016 introduced temporal tables as a new feature that really makes this entire scenario super easy. And there are two aspects of improved productivity when it comes to tracking data that changes over time. First is SQL Server and Azure SQL Database allows you to track data changes without any additional code in your application. So that's one thing. And not only that, you can also start tracking data changes in existing application without impact to those applications, completely transparently. And another thing is consuming and analyzing historical data is now easier than ever before, because we introduced a convenient syntax for you that you can use to zoom in, to focus your analysis to any point in time, or to analyze trends over time. So there are many scenarios that can benefit from temporal. I would just list a couple of these here. And first, it's really adding data auditing capability to your application. If you need to audit data changes, then using temporal should be your first choice. Not only that, if you have application that needs to be improved or extended with data auditing capability, temporal tables are also an option for you. You can use temporal for any kind of we call it time travel type of analysis. And this is typical trend analysis. If you need to easily understand the patterns and trends and anomalies in your data that happen over time, temporal tables are a great choice. Finally, in data warehousing and analytic solutions, there are certain patterns for changing, for tracking data changes. We call it slowly changing dimensions. And basically, now you can use temporal table as a building block, coding block, that can completely replace custom solution for slowly changing dimension. That's completely possible to do now. Finally, since you are tracking data changes over time, you can easily rely on temporal to fix any issues or errors in the data that are introduced either by human or applications, because you can easily, having full history of changes, you can easily restore the valid state of the data at any point in time. Of course, you could do that prior to temporal by pulling backups, restoring databases, and doing that kind of a complex stuff. But for the first time, you can do that at a very fine-grained level, at the table level, even at the row level, which is something that you couldn't do before. What is a temporal? How it works? First of all, temporal is a new type of user table. To be completely honest, it's a pair of tables. The main table, we call it current table that holds the current state of the data, is the table that you interact with, your application interacts with. But there is also one shadow table that is transparently created for you that is there to store all historical changes automatically. Now there are basically, it's a matter of a single DDL operation, either create table or alter table to create this table pair. It's very easy for you because by default, system will create matching history table for you without any intervention from your side. But it's also flexible. It allows you to customize historical table if you wish. In most of the cases, there's no real need for that. But if you wish to customize history table, to create additional indexes, to change the type of storage type, whatever, you can do that. Once you created this temporal table pair, here is how it works. I will just make a short walkthrough to the main database operation. When you insert new data into your table, basically only main table is affected. That means you are inserting a new fact that never existed before. It is a new row without history, right? So it affects only history table. I'm frequently getting questions how efficient temporal implementation is. And you can see from this slide that inserting data is actually the same as with regular tables, right? No impact, right? When you update or delete a row, or if you issue any statement that actually changes the state of the data, what happens is that it happens that previous version row goes automatically into the history table for you. And that's the way how history is being built. Now, when you want to access data that is stored in the temporal table, you can use very simple and convenient syntax, which is a new for system time clause that we introduce. And when you use that syntax, what happens behind the scenes, no matter how complex your query is, SQL Server is will actually resolve all that complexity for you. All necessary joins between the latest state of the data and the historical data, which depends on what you need, what you want, will be handled by SQL Server. So from the application point of view, from the user point of view, querying the data is extremely simple and efficient, and we will see that in upcoming examples. So I think before we move to the integrated scenario, maybe it's right time to take question about all three features, if you have any.
Sure.
Can you give some examples of what data you would see in the temporal or the history channel or the history table? Would you see like who changed it? Obviously time and values, but you can
Yeah. So the question was what we can see in the history table, what type of information we can see. Today, we do see the dates when the row was created and when the row was modified or deleted, and all columns that belong to that row. The question was, can we see the user information? So if you manage user information from your application, that information will be automatically moved to the history table. It will be maintained. We do consider as a future improvement without any timelines, and we do consider extending temporal tables with handling user information, not only user information, but we call it operation context information automatically for you. Okay, that was a good question. The question was, can I specify for how long I will keep the data? Today, with this version, you cannot. Managing the retention for temporal tables, it's something that you can manually do. You can partition history table, and you can do partition switch out to remove the oldest part of the data. But again, a new feature is coming. We call it temporal retention. It is about to be available any day in Azure, any day, very soon. And exactly as you mentioned, it will be another parameter. When you create or alter table, you can specify, I want data to be kept here for 3 months. After 3 months, data will be automatically deleted. Yeah. Okay, so the question was, does it work? Does it have a trigger behind the scenes? Does it work like trigger? Actually not. It's not based on triggers. We did an effort to modify execution plans for every data modification operation. So appropriate insertion in history table is part of the execution plan now. It's not something that comes afterwards. That's one thing. And another question was the performance penalty. So, of course, since every DML operation now needs to touch 2 tables, there will be some additional costs. So typically what we do see for insert, as I mentioned, no performance penalty. For updates and deletes, we do see typically around 20–25% of additional performance, of additional time typically that is needed to complete the operation. But we also measure that and compare it with any other custom solution that you can build. And basically, Temporal is much better than anything that you can build, either triggers or application logic, yeah? Yes, yes, yes. The question was, can you use temporal within memory tables? Yes, you can do that. You can create a temporal table as in-memory table, in-memory system version table. We call it system version is a keyword that we use in SQL Server. That's a specific type of temporal. So you can create a table that is both in-memory and system version. For that particular configuration, history data is not being preserved in memory, but rather on disk. Because it's not, we just concluded that keeping data in memory, temporal is really designed for you to keep data for many months, many years. So keeping data in memory wouldn't be optimal solution. Sorry? Yeah, of course. I mean, that's, yeah.
So before we move on, as much as we like Barco and Temporal, you're welcome to ask questions on any of these areas. We just want to make sure folks are clear on the 3 different technologies areas before we move on to the integrated scenarios. So, sir.
I had a question about always encrypted, actually, and I wanted to know what is the role of always encrypted in relation to TDE? Do you need TDE anymore? Do you have to have it? TDE is kind of a major pain. We have sort of professionally acceptable this version. So
Yeah.
I'm trying to figure out what the correct plan is going forward.
I tried to motivate that early. I don't think I succeeded well. So we're not saying TDE is gone or ignore it. It has a room. There's room for TDE. It's mostly on the compliance sort of checklist level. It does have some advantages. Namely, it's completely transparent. So that's something you turn it on, and as long as you're aware of the fact that it's only encryption at rest, so only files, data files, backups, and so forth are protected. And they only protect it in the case when somehow they get lost on some device that somebody inadvertently takes or steals under certain conditions. So you protect it there. The drawback, of course, is that anytime, since it's transparent, and that once the data gets paged into memory, everything is in the open, and so there is some use for TDE, but it's somewhat limited. The always encrypted, on the other hand, so always encrypted and TDE play very nicely together. So our recommendation actually is to use both. And recently we've made some changes to TDE. We're actually taking advantage of hardware that Intel delivers now that's available in Windows Server 2012, where we can actually take advantage of it as long as you run on Windows Server 2012 and up. That allows us to actually cut down on the overhead, encryption and decryption overhead. So it reduces the performance impact somewhat. And again, it depends on the workload that you're running. So we've made some improvements on performance. We also fixed the issue, this nasty little fact that if you compressed your backups and then if you used encryption, the compression wasn't very good because we did it in the wrong order. So that's fixed as well. So we're still tweaking things here and there. We haven't given up on TDE. Again, I think we could do a better job probably educating people on the value of TDE. And again, I think I want to make clear here that this is something that a lot of the compliance requirements will state that you need to have encryption at rest. TDE will do a good job there, but you have to be careful. It doesn't really cover a lot of other scenarios. So always encrypted, TDE work well together. Always encrypted is the preferred choice if you have sensitive data, certain columns containing sensitive data, and you want to make sure you protect this. So in the case here, it wasn't an accident that we sort of talked about stretch and always encrypted, because this is a scenario where data is moved into the cloud. A lot of people fear the loss of control over data in the cloud. Always encrypted will give you the capability to actually encrypt this with an encryption algorithm, an AE256 type encryption algorithm, hold the key. And so no matter what happens to your data in the cloud, no matter what happens to SQL Server, you can rest assured that that data is protected in use, at rest, in transit, and so forth. So that's sort of, I think, a quick answer here.
Right. I'll take the gentleman right at the back first. Second from the back row.
You mentioned made some performance improvements. Are there any benchmarks
So 2 parts here to the question. First, performance studies on always encrypted.
Joachim, repeat the question.
Oh, sorry. So first question was, are there any performance studies or have you done performance benchmark on always encrypted? The answer is we're in progress there. I think Jakob may have a better answer, but in the interim, we are working on some performance benchmarks for always encrypted that we will publish pretty soon. There is some overhead, as you can imagine. It's a little different from typical encryption because we've moved everything over to the client side, so this is something that you need to take into consideration. On the server, the overhead is very minimal because, again, nothing really happens on the server. The information is stored, so there's some storage overhead and then just a minimal overhead in processing cells that are a little bit larger. Second part of the question was, when you modify your database schema that has always encrypted columns in it, as long as you don't touch those columns, you can make schema changes without any impact. Now, if you want to make changes to the data type of the encrypted columns, that is not possible, of course. You'll have to first unencrypt, take the always encryption off, then you can make schema changes, and then you have to encrypt again.
All right, one at the back and this one, and then we'll move on and we'll come back for questions.
With temporal tables, what happens when you change the structure of the base table?
The question was what happens when we change the structure of the main table. Currently, that change is propagated to the history table automatically. So you can use alter table to propagate the schema change to the history table without specifically changing the history table. Now, we do not version schema changes. We only version data changes. If you are adding a column that is not nullable column, obviously you need to specify default for that column, and default will be applied to the existing rows, both in the current and the history table.
Last question.
Does the always encrypted temporal tables and StretchDB all three work together?
That's what the session's about. The question is, does always encrypted, StretchDB, and Temporal work together? Well, we're going to show you how it works together.
Just one thing, I wanted to mention that tomorrow morning there is a session on developer productivity, and big part of that session will be devoted to Temporal. So if you're interested to see more details about temporal tables, you can come tomorrow morning, 9.
Okay, so
And I want to say that the question from Suba, that was not a question where we paid him money to ask that. It was just purely for interest. So, but it was a perfect segue to the next part here. Thank you.
right, so we've walked through the different building blocks, and the problem we're really trying to solve is you can securely keep data indefinitely without breaking the DBA or your banks or your budgets. And the idea is, if you wanted to be able to query back in time, and one of the things I want to make sure it's clear to everybody here, a lot of this stuff you can do on your own, as Borko and Joachim alluded to. You can write scripts and you can write stuff, custom code in your applications to do this stuff. You wanted to go back in time for your database. How many of you had to restore a database at one point because somebody wanted to find out value for an account at this point in time? How much fun was that? How many terabytes was your database? And just because somebody wanted to find that one row, and wouldn't it be easier if you just say, hey, select from this row as of this point in time? That makes life a lot easier. But if you kept data for 10 years, then you probably would still be in trouble. So that's where Stretch comes in. So after you enable Temporal, where you have both history management and query capabilities to do time travel, then you would also think about, okay, do I need to go extend that and put that big chunk of historical data? Because even in the history, you may potentially have lots of versions, and some are warm and some are really cold. And the cold stuff you may not query very frequently, but at some point somebody may go back and ask, hey, what happened last year with this particular environment? And you don't want to, again, go back and restore something to go find out what happened there. And of course, if you care a lot about security, you can protect it as described by Joachim. You own the keys. This is not something that we have access to. You keep the keys within your application, and the cool thing is the workload of encrypting and decrypting it is on your client, so you don't end up flooding the server. So you can scale the number of users that you have. You're not going to go bring the server down just because you have always encrypted implemented. Individual clients that process a lot of data, okay, fine. They may experience a little bit of a slowdown, but you're not going to affect everybody else. So, but the key point there is all of this stuff, you have these capabilities, you have extensions to Azure, and now you have encryptions locking the data away, make sure you take care of your keys. There's no such thing as a backdoor from Microsoft. And people kind of chuckle and say, nah, come on. You won't say that in the crowd, and this session's recorded, so you're saying that. No, we've had people actually call us and ask us for help because they lost their keys. They forgot to back up, and things got deleted, and they were like, oh, yeah, you guys have a backdoor, right? You've got a master key, right? No, we don't. If you lose it, go hire somebody to go hack into your database. Or, we'll find somebody to help you hack into it.
Don't say that.
Well, if you lost your key, what are you going to do? So, and it is hard. We've had these kinds of situations, so we don't have a backdoor to get in there. Some government agencies with the 3 letters may know how to help you there. I don't know, perhaps, but we can't. So, and the other really cool thing is the transparency aspect. I hope that came across clearly. The idea is we want to minimize the impact to your applications. Cracking open application code is really painful. A lot of times you don't even have the code anymore, or you have the code, but the people who wrote the code are long gone. And having to go crack all of those things open can be painful, so we try and minimize that. The same queries will run as is. If you want to take advantage of additional capabilities, you got to go write new T-SQL. But if all you want to do is enable these existing capabilities and stretch it or have history managed by itself, then you don't actually have to go modify your application code, which makes life a lot easier for DBAs, because you can secure your stuff, you can keep data indefinitely without having to go spend a lot of time rewriting applications. So, what's the sequence of implementation? It's fairly straightforward. Now, the first 2 steps could flip back and forth depending on your environment and your requirements. Essentially, it really depends on what your main problems are. So you can always encrypt your data, implement always encrypted for your data initially as a first step. So pick the columns like name, social security number, or credit card number, whatever it may be, and encrypt that portion. Once that gets done, then you would enable temporal tables against that same table that is already encrypted, has the column already encrypted. And after that process is done, you would then stretch that table into Azure. Again, you can choose to stretch the entire history table, or you can stretch specific rows within the history table. That's your call. For the most parts, we find customers will prefer to stretch specific rows within the history table. For instance, if you're in the financial services industry or if you're in healthcare industries, you potentially have records that span decades. People maintain accounts with you for decades. People will have medical records for decades or more. So you would potentially look at that and say, hey, data from 20 years and older, we can go stick that in the cloud. You're not likely to go query that on a regular basis, unless there's some major issue and we want to go back and query the entire time, or God forbid, there's a lawsuit because of whatever issue, then you want to query everything back in time. So things like that you need to consider, but essentially the order really is either always encrypted and temporal first, and then implement stretch database last. So not a whole lot to remember, just keep this in mind. The first 2 can flip, but do not flip the stretch database portion around. We okay so far? Question? Okay, so the question is, what happens to my backup and restore strategies and techniques? Nothing changes there. So for stretch database, even though part of your table resides locally and part resides in Azure, whatever existing backup or HADR strategy that you have still applies. So if you back up your local database on a weekly basis and then do transaction log backups daily or hourly or every 15 minutes, you could have differential backups. All of those things continue to work as is. You don't make any major changes. The only difference is now you potentially have 80% of your data sitting in Azure, which you no longer need to back up. We will take care of that for you. When you do a restore, you need to run a procedure, which I'll describe later in the section, so that we know how to auto-reconcile. You don't actually have to do anything special apart from running that procedure. But essentially, nothing else changes there. Absolutely. That's one of the biggest wins for some of our customers. We have a federal agency where their database, if they have to do a full DB restore, it takes them offline for a day. And that's because 85% of their data is cold, and they're running to 20-some terabytes, and they don't have the fastest and latest and greatest SAN. They have a SAN, but it's not the best, and it's shared with multiple databases, which none of you ever experience, right? You all have your dedicated SAN frames. You guys are good. but our poor federal agency does not. It takes them offline for a day, but now that we've stretched 80% of that in Azure, instead of 20-some terabytes, they're only back at restoring less than 5. So it's a big difference. 2 questions, and then we'll move on, sir. Is there an on-prem option for stretch database? Can we stretch to SQL Server? Not yet. We get that pretty frequently, so if you feel strongly that that's important to have, go to connect.microsoft.com and vote for that capability. We know what to do with that. We worked on the prototypes. We know how to do that. It's just that the sequencing of work, it just happened that we hit Azure first. And we can talk offline after this, but you lose a lot of the free maintenance and easy DR capabilities if you stretch to your own SQL Server. But you still have others that you can gain. Will it work with Azure Stack? Eventually. Right now, Azure Stack doesn't have some core services that we need. When they do, then these features will be lit up there. Sorry. One more question and we'll move on.
Can we split both temporal and history table?
Sorry, say that again?
Can we split both history and the temporal table?
So can we stretch both history and a temporal table?
Not today. So basically, we do support only stretching history table.
So
But
what
I
would the
be
scenario
interested
be for
to hear
stretching the
scenario,
main
yeah.
table? Because the main table is hot, and stretch database is intended to go after cold data. If every query that comes through to your local SQL Server has to make a round trip to Azure, your users might be a little upset. Unless your entire infrastructure is already sitting in Azure, in which case then you don't notice the latency difference. Otherwise, if the query, if everything is stretched to Azure and every query has to go to Azure and back, that would be a pretty high latency price. Sorry, let me finish this. I'll get back to you, sir.
What if you filter the data and move the cold data to stretch?
So why don't you filter the data and move only the cold data? That's effectively how Temporal already works today. I get that there are sub-scenarios where the primary table could also have some cold stuff, but that's fairly edge case, and right now we don't support that. But that's a good point, and if that's something that's valuable to you, send us the feedback, either user voice or connect.microsoft.com. That's stuff that we can get on the roadmap and we can triage. Thanks. Okay, so let's take a quick look at how we actually put these things together in the scenario. So we picked one of the things that we worked with in our early betas with customers, hospital records for patient stays. So you maintain the stuff, patients and the rooms and the wings they're in, and the vast majority of the data is cold. But you do need to keep that online for decades. You want to keep some years hot, but the rest of that stuff needs to be kept somewhere else because you can imagine over decades you would have a lot of data. And of course, personal information must be protected. So let's see what things look like. All right, so we don't have pretty fancy applications and web pages and whatnot. We're just going to show you what the product actually looks like so you can go back and implement yourselves. So right now I've already got the tables set up, patient stay and patient history. So if you were to cobble your own solution, which is very common today, if you were to go build your own stuff, this is pretty much you already have your main hot table, patient stays, and then you've created a patient stay history and you populate that by either using triggers or SQL agent jobs where it will wake up and go find, this stuff is cold based on whatever criteria, and I will grab that and push it through. If you want to create your own temporal equivalent, you would probably have triggers that every time it doesn't update or delete, then you would grab the previous row and bring it over to history. So, and they're fairly small tables. The hot table is about 10,000 rows, and the history table is just over 1 million rows, so it's fairly small, not really anything interesting or exciting. But just to show you out here, so if you look down here at the bottom for the initial table, this is about 10,240 rows, and history is just over 1 million rows out there. So let's go ahead and figure out always encrypted first. I'm going to walk you through the wizard.
Actually, yeah, so you'll walk through the wizard and I'll annotate a little bit with some additional explanations. So so the wizard, before you start the wizard, it's essentially encapsulates a bunch of operations that you can do without the wizard. The wizard just makes it nicer, and I'll tell you a little bit more about some of the stuff that's happening behind the covers. So essentially the wizard encapsulates 3 distinct pieces of workflow. And so as we step through it, Joe invoked the wizard on the on the database level. So you get an overview of your schema, and now the first step is you choose the type of the columns and the type of encryption that you want to do. So in this case, we're encrypting name with deterministic encryption in the patient's table, and then also name in the patient stay history, same encryption type. And what Joe is doing right now is he's basically accepting the keys. So this first step is all about key generation, so key selection or selection of columns, and then key generation. I mentioned earlier there's a key hierarchy at play. Just like with TDE, we have a master key, but it's protecting an encryption key. And so what we're doing here is we're generating these two keys. None of them exist. And so we're accepting the names here. A little bit about the keys themselves. The encryption column encryption key, as I mentioned earlier, is stored as part of the metadata in the schema in SQL Server, and the wizard will handle that part. It's also protected with the master key that we're generating here, and the master key is under your control. So in this particular screen, you get a choice of where do you want to stick this certificate, this master key, and here for simplicity, we're putting it in the Windows certificate store. As long as the key is available to the client, all that transparency that we saw earlier is there. You also have, and actually we moved on already, there was an option to store that key in Azure Key Vault. And there's also, if you want, you can also choose an HSM to protect the key. So we're part of we're done with the key creation. So the next step now is to augment the schema, those two tables that we've chosen, with information about the type of encryption algorithm that we've chosen. First of all, the columns and the type of encryption algorithm. So that's another step that this wizard does for you. And then here you have actually, it gives you a warning about, hey, when this encryption is in process, this is a serious operation. At this moment, at this point, basically the table is locked, so don't attempt to do anything there. And the other option you have here is you can say, well, I'll use the wizard to sort of learn about Always Encrypted, and once I understand this, I can actually have the wizard generate a script for me, which I can then run at my leisure, either because the encryption takes too long, or I want to do this a bunch of times, so there's an option for you to create a script. This is the usual summary table that gives you an overview of this is all the stuff that the wizard is about to do. And now we're in the third phase of applying Always Encrypted. This is the actual encryption phase. Now, a quick word here. This actually involves a bunch of steps. This involves taking since we're talking about a table that has, or two tables with a bunch of rows in there, this involves creating two separate temp tables, taking the data, exfiltrating the data, routing it through the client and back into your schema. And this is because, as you remember, this encryption is a client-side encryption, and the server never has access to keys in the clear, and this data will never show up there in the clear. Now, that last part is, of course, not met here because we already had the data there. But nonetheless, we need to route the data through the client, and this is what this wizard is doing right now. This is why it's taken a little bit longer. And so as this completes, we will have routed, 1.4 million rows through the client driver and back into the table, except that when it comes back into the table, these two columns are now encrypted. So that's what the wizard does, and everything we talked about here you can do without the wizard, of course. You can use T-SQL to create the keys, and there's actually SSMS has a nice GUI built in. You can use SSIS to do the routing, and you can also use T-SQL, of course, to augment the schema.
Question before we continue.
Not to be too simplistic, but what is the expectation of the client-side driver out to the clients?
So the question is, what's the expectation with for the client-side driver in terms of performance, you mean, or?
Or just, how is it typically deployed?
So.
Is it a part of the application? Is it built into? Is it pushed out through the system center or something like that?
So obviously, so we're using SSMS here that comes with an enhanced client driver. So if you're using the latest version of SSMS or SSDT, some of the tools that we ship will have the updated client drivers built in. We are also offering you, so if you do your own, you can download these drivers from our website. And we're not just supporting ADO.NET, but we also have ODBC and JDBC drivers available, these enhanced drivers that you can use. I forgot the version numbers,
So
Jakob.
just treat it like you normally would any driver. So it's a refresh one. You need to make sure you have the right version. But however you currently manage your drivers, you push it via SCOM or whatever it is, HP OpenView, stuff like that. It just do the exact same thing. There was one question here, and we can move on.
So the question, how can I do this so that some users will see encrypted data and some users of my application will see the unencrypted data? So it's all about, at this point, we don't separate on the users in terms of I can sort of exempt this user versus this. It's all about who has access to the certificate on the client driver. So the easiest way to accomplish this is to set up your two groups of users. One user group has access to the certificate store in this case, and the other group of users doesn't. So that's the easiest way you can make that distinction there.
Okay, so let's go ahead and fire up Temporal real quick, and we still have time for some questions.
And I guess we see here now, so you ran another query, and so now you can see those two tables with the encrypted data there.
I did, and it was the identical query, so you now see the name is in ciphertext. And if you're wondering why we're encrypting the name, we're kind of mixed here in the US, but in most parts of Europe, name is considered sensitive information that you need to protect, and encryption is a requirement if you push it up to the cloud, whereas patient ID only makes sense to whatever organization that owns it. So it's almost a form of tokenization where the only way you can reconcile a patient ID and all of these records is with whatever reference that you have a patient ID mapping to the actual patient that sits on-prem. So you can push all of this stuff in the cloud. If somebody stole it and somehow stole your Azure account, your subscription information, all they're going to get is a bunch of ciphertext, which they can't tie to anybody or anything. So let me go ahead and fire up two SQL scripts that will actually go ahead and enable temporal tables against our existing both current, the hot data, the current data, and the history data that sits in the back end, or, well, it will be hidden eventually. If you look out here right now, and this
and nothing has been stretched so far, Joe, right?
Nope.
Just to make
so
sure.
We're just going through temporal, and patient stay history. I'm just going to go ahead and set this on. It's fairly straightforward, and it runs quickly.
Just let me comment quickly about this statement. So this is a very specific scenario where you can use temporal to apply built-in support for temporal data to your existing tables. And you can see from these statements that Joe just ran, that basically there are two statements, two alter table statements, one for adding a period definition with existing columns. That's important. You don't need to create new columns if they are already there. And then another alter table that actually links two tables, one being current and another being history. So that's the example how you can customize, how you can migrate existing solution, how you can further customize temporal if you don't want to rely on what system will create for you. Sorry?
Scroll up of which site, the code? Ah, gotcha.
On the creation, the history table will be empty. The history file will be empty, so it will be still in the process.
So what happens with the second statement that links to table, if table with the name DBO patient stay history exists, it will be just linked to the current table. So data is there. Nothing will be truncated. Data is there. If table doesn't exist, if this table doesn't exist, a new table will be created with the matching schema. The second scenario is important when you didn't have history, you want to start tracking history from today, you just issue a statement and specify the history table name, one new table will be created for you, and from that point on, you'll be able to track the data. But we are talking here about real migration scenario. You had the data before.
So remember, there are two ways you can start. Either you only have everything in one table and you want to start tracking history now, in which case, as Borko mentioned, we will create an empty table for you and then start tracking history. If you already have it, like our current demo, then it will just make sure that, this is the hot current, this is the history, and we will establish the links and then continue from there on. And if I do a quick refresh here. Oops. Notice my patient stay history is gone. So it's hidden that away because now it's system managed. And this query that I just ran basically tells me the state of this particular patient with this patient ID throughout the entire history of decades of data that I have. It's not terribly exciting. This patient evidently is pretty healthy, hasn't been around our hospital for too long. But if you look at the execution plan, there's nothing special that we have to go do, but if you look down here, whoops, on the object level, it actually goes out there and queries patient stay history automatically. So instead of you having to go write these queries to go join the tables or go pull from some other remote data source, play with link servers, you know, if you really like that, all you really got to do is once you enable the temporal and we start managing history for you, the QP is also smart enough to realize, there's your history table, and it knows how to go out there and do the right joins for you. You don't have to go write custom code to do stuff like that. So, and we, question, sir?
That performance issue was coming because of the can we change it now? Can we add an index?
Yeah, of course. As I mentioned, you can create index. So yeah, for the purpose of this demo, we didn't optimize too much the scenario. You would create appropriate indexes. And just one thing to mention, default history table is created with default index that is optimal for temporal querying, okay? It's a cluster index that contains period columns. It is optimal for that purpose. In this case, if you provide your own table, this is bring your own table scenario. We don't add additional indexes. It's actually not disappeared. You can find it. Joe can help you find it. It's beneath, it's under the main table here. If you expand the node, you'll see that it's now a kind of a child. It's a dependent object, doesn't exist on its own. And you cannot change the schema of that table. You cannot modify data in that table regardless of the permissions you have while versioning is on. That's actually the point behind using temporal for auditing scenario. You have permissions, but you cannot change the history data.
Okay, I'm going to run one more query that Borko here would explain, where you can actually use Temporal to actually build trending data without having to go figure out how to manually go calculate these points. And this query essentially goes back and looks at your patient utilizations per wing within each room across the entire history that we have. So
the point is that temporal querying is really nicely integrated with all other querying capabilities that we have. And this example illustrates how you can use the windowing functions that you regularly use with the non-temporal tables here with the temporal tables. The only difference here is you do provide for system time all as a full history or for system time between and end, whatever period you specify, it will be processed in appropriate way. So
what we've done so far, we've encrypted sensitive column name, and then we've put the current table and the history table, and we linked them together, saying that, hey, you guys are now temporal tables. So then you notice in Management Studio, the history table becomes a child of the current table, which is the hot data. So that's what we've done so far. And now we're figuring, you know what, this is going to grow into billions and billions of rows eventually. Not that I'm hoping that people fall sick, but you know, hospitals, sometimes we have people come in for extended health checks, let's put it that way, proactive. So for a stretched database, there are a number of things you need to do up front before you can actually move data to Azure. As we mentioned earlier, we want to make sure things are always secure. And I'm showing you the T-SQL scripts that you would typically use to do some of these things. You would need a database master key. We use that to secure the credentials that is used to access the database in Azure. So what happens is when you actually stretch a database, we would create a corresponding database in Azure, and then each time a table gets stretched, we then create the tables within that database, and we move the data automatically for you. So we do support both SQL Server and Windows integrated authentication. If you have your local AD integrated with Azure Active Directory, then you can do pass-through authentication. We don't allow you to provide a user credential at this time that's a Windows domain credential. What we do is we take the service account credential and grab a token and swap that in Azure with STS, and then use that to present to Azure as the credential that we'll access with. So it's integrated, it is not a Windows off. So we have two options, and once you've created the credentials, you can take a look at what I've already done up front, and you can go check to see what's out there and see who else may have set something up for you. Important thing to remember, you need DBAs to enable stretch at the instance level. and you need DBOs, database owners, to enable stretch at a database and table level. So we adhere to the security hierarchy. You can't have some random person, some DB writer or some DB operator comes in and starts stretching and putting your stuff in Azure. That would be a little scary. So we follow the hierarchy. So the DBA says no, nobody within that instance can do anything. So we can test connection, make sure things are working, and to actually stretch a database, which I've already done earlier, these are the two ways or two authentication methods I described earlier. Use a secret credential or use federated identity on for Windows integrated auth. So I've already done that in the interest of time. And what happens is now we can go ahead and figure out, what are some of the things that I've done against the server? There's a bunch of DMVs and catalog views that we provide to you. So you can go check to see, what do I have currently set up? Where is my target in Azure? What are the names and so forth? So none of this information is hidden. If you have the permissions, you can go figure out what exactly is going on. To stretch either the entire table or parts of the table, as in specific cold rows within the table, if you want to stretch the entire table, all you got to say is alter table, set remote data archive on, predicate equals null. So there's no predicate. And what the predicate is, it's just a simple table value function that identifies what rows are cold. Today, we only support deterministic functions. We don't allow you to specify anything that's non-deterministic. We're working to relax that in the future. But creating a function is fairly straightforward. As you can see here, I've done this earlier. And essentially, this criteria here, 12/31/1996, is the date that I'm saying anything older than this, move it to Azure. So I'll keep 20 years of data on-prem, and anything older than 20 years, I'll move it to Azure. If you create that, and all I got to do is now run the same alter table, filter predicate equals to DBO function stretch predicate start date, and if I hit that and tell it to go, it would now go ahead and start stretching. To check to see what's going on, all I got to do is run a DMV, and you notice the first one tells me I have a table that's stretched. The metadata is updated, so the database knows I have a stretched table. The second one is a DMV that tracks data movement. So this will take anywhere from 15 to 30 seconds. So we have a system thread that wakes up and looks for work to do. Work includes stretching a table. Work includes moving data across. We move them across in either 5K or 10K row sizes just to minimize impact on existing applications. So let me try that one more time. It's woken up. Now it's going to go ahead and create the actual table that needs to go remote and starts moving data in probably another 30 seconds or so. We're okay so far? You're with me? Question? Okay, good. So now, well, let's try this one more time. It's going to take a few more moments. It's going to move rows. It should say 9999, and the reason we have 9999, it's because we try to make sure we don't escalate to table locks. So we have two batch sizes. One is 4999, because 5K rows is the lock escalation, and there are some situations where even the hints will not be sufficient to prevent lock escalation. So we make sure the number of rows that we have, and then in some cases when we know we can guarantee no lock escalation, we bump it a little higher, and we decided to keep the 9s anyway just for fun. There's no particular reason why it needs to be 9. It could be 10,000 or 20,000. So as you can see, some rows have moved over, and this is the same query I have on two screens. I ran this earlier before stretching it, and I wanted to point out that if you look at the query execution plan, it's not very exciting, and the perf tuning folks that are out here will probably be cringing and saying, oh my God, you're scanning. And well, okay, we did not optimize this. This is just for show. Don't beat me up just yet. If I run this query now, the exact same query against the exact same database and tables, and you notice it took just a split second longer, but if you look at the execution plan, you magically now have a remote query operator. So essentially, we taught an old dog very new tricks. The query optimizer specifically understands that this table is now stretched. It knows where to find the metadata. It knows that, hey, there's data in your query that you're trying to retrieve that sits remotely. I'm going to go farm this out. As I described earlier in the slides, I'm going to farm the query out to both places, and I'm going to retrieve that for you, and then union all and get the result sets back out to you. So you don't have to do anything special. The existing queries just work. So that's the other cool aspect of it. And all of the query tuning practices that you've learned and employed in the past, all of those things still work. So if you write very good queries, then your impact will be whatever the latency between your data center and Azure is. If you write rebar queries, perf is going to be really bad for you. Anybody know what rebar is? Row by agonizing row, thank you. So stay away from those queries. If you have bad queries, performance will be horrible, and stretch is not going to help you there. So that really is all it took, and we can run a whole bunch of other queries, but essentially, that really is all it took to take an existing set of 2 tables, or if it's just 1 table, encrypt the columns that you care about security deeply, or somebody else cares a lot about it and wrote a regulation that says you will now care. It happens sometimes. So, and you take that, we enable Temporal on it, so you have automatic history management for you and time travel query capabilities. And now we've stretched that history table, just the rows that are greater than 20 years old, and put that stuff in Azure. That way you're not paying for your expensive local SAN for historical data that's 30-some years old. So those of you who don't know, your typical SAN cost, enterprise SAN, not your buying disks from Fry's, enterprise SAN cost can be anywhere from 50 to about 80 cents per gigabyte per month if you look at overall cost, including the cost of people, TCO, power, and everything. That's a lot of money to pay for cold data. So that's the very simple demo. And you can, by the way, you can stretch it using the wizard. This is Microsoft. We love wizards. So if you really wanted to, you can chase the mouse around and go run the stretch using a wizard. Just task, go to stretch. We can do all that. I figured I'd show you the code. Most DBAs like to see the code because you can automate and avoid mistakes. Any questions before we go back to slides? Yep. That's mostly relative cost because the query is, so the question is, why did it show the cost is 0? Because it's a relative cost, and I'm scanning a much larger table locally. Remember, I just started this, so it's only moved a few thousand rows over, and the local still has the million of rows. So, sir. Does this work well with CRM, as in Microsoft CRM? It does work, but it's not certified yet, so we've been working with them for some time. Both our internal Microsoft admin team that manages our CRM instance and also the product group that builds the CRM application. So we're working with both of them to enable this as a supported feature. Right now it's not, but we've tested it. We haven't really found any showstoppers, but don't go ahead and implement without having them certify first. Just like any ISV, they don't treat us any special. They need to certify before it can run. Any idea when the certification will take place? Don't know. Drop me a mail, and I will find the right people to get those dates for you. So let's go ahead and wrap up this presentation. So very quickly, this is what actually happened to the schema and data after we've encrypted, enabled, temporal, and stretched. So on the right side, you can see the table becomes significantly larger, and over time, all of this stuff will sit in Azure, and it's blue, because Azure is blue. And the rest of your stuff on local that stays with you, your hot data will reside with you. It's white hot. Okay, so not everything is free and pretty, so we're not going to go through every single thing here, but there are important points for you to remember. Monitoring doesn't really change for your basic operations, but bear in mind that now that you're looking into Azure, you'll need to poke into the Azure portal if you want to figure out your billing and utilization levels. Everything else pretty much stays the same. The same guidance applies how you monitor using DMVs and X events and so forth. Backup and restore, there was a question earlier about what happens when you do that. First thing, as mentioned earlier, don't forget to back up your encryption keys. You lose your keys. We have no master key. There's no skeleton key anywhere. You lose it, you lose it. And the other thing is, if you have stretch enabled, after you complete your restore, roll your transaction logs, get to the point in time, then you need to run SP reauthorize to basically say, this SQL Server database is the official and recognized database for that Azure instance. And it does that security reauthentication. It also triggers reconciliation, which means we figure out how to reconcile the local and the remote to make sure that they're transactionally consistent. And we don't do a size of data copy operations. We have internal trackers to figure out what's going on. So if you went back in time that resulted in terabytes of database change, traditionally you'd have to go do data copy of however many terabytes, lay them on disk. In this case, whenever you're done local, we do a metadata lookup and figure, your watermark is here. Let's go ahead and reset that, and all of that stuff is done. There is no size of data copy operation there. So you can recover 100 terabytes of data in Azure in minutes, literally 2 to 3 minutes, assuming your connectivity is still on. We talked about performance. There were guidance from both Barco and Joachim about perf, and for stretch, hopefully it's obvious. If you're hitting the data frequently, don't stretch it. It's meant for cold data. You stretch hot data, your users will be really mad at you. You could if you really don't like your users, but we don't recommend it. Some known issues and limitations. Everything here is documented in MSDN, and there are links at the end of the slides. When you download them, go look them up. So keep these things in mind. Certain types are not supported, and there's certain features like replications we don't support currently. For the most part, these are transient. We are working hard to remove as many of these as quickly as we can. Just bear in mind that there is a law of physics at play here. There are only so many engineers that we can have working on so many problems. So we'll try and knock them out over time as quickly as we can. But do pay attention to these current limitations if you're choosing to employ it today. And of course, if some of these limitations are more important to you than others, let us know. Help us prioritize which ones to knock out for you first. Key takeaways. Hopefully, this is now very clear. To be able to keep data indefinitely for as long as you want, as much as you want, you don't have to break your budgets or your DBAs or your developers. This stuff is fairly easy to implement, as we've shown you through, and you can actually take the scripts that we have and go ahead and roll that out in your environment, and they will work. The key thing also is to remember, we designed these things to work together. We have done our internal testing and breaking each other and fighting and screaming. No fighting and screaming, but we go through that internally to make sure things work before it lands on your data centers. So these are things that we work very hard so that you have a solution, not a bunch of tools for you to go cobble together and figure out how to make things work. And the fact that a lot of these things are transparent to your users hopefully is of value. It's really painful if you have to go crack open code or teach users something different just because they want to now keep 20, 30, 50 years of data. So hold on to the question. I just got one more, and then we can get to it. So check out some of this stuff. We have links to materials available, and our email addresses are on the slide, so feel free to ping us anytime. We are just over time here, but we will hang around for a couple of minutes if you have additional questions, and certainly swing by the booth anytime. We'll be here till Friday. So thank you very much for your time, and my co-presenters, thank you also.
Thank you.